Welcome to another HackerRank video, Blind 75 video, in which we solve find target and rotated sort array problem. Second and last problem related to the binary search. So, generally speaking, when we talk about this problem, let's open our here. Then this color here, right? Generally speaking, given an array of 1, 2, 3, 5, given an array of these numbers, right? This is also already sorted array. We are given another array, and I want you to keep in mind this array that we just covered here. We have another array, which is 3, 4, 5, 1, 2. So the question here is, how does this new array compare to the array above? Compares in the sense that we have potentially, give me a second, we have this section over here in its entirety to this area here, right? And this has changed this is how this array looks like when this change has happened, which means it has been rotated, and this rotation is of the order 3 basically. So there is third order rotation that we did here. So given multiple arrays like these rotated arrays given to us, we're given a target number that could be, let's say, 2. We need to find that target number, identify it, and send it back. And if we don't find the target number, we return the value of -1. So based on these factors, how do we how do we uh, how do we how do we uh, how do we solve this problem? Basically, that's what we need to do. So the first thing we need to understand here is, let's write down another array here. We can go over it. So supposedly we have an array here, and again, like you need to understand, like any problem like this is going to involve binary numbers. So, and when we talk of binary search, when we talk about binary search, we always need to remember there's 3 pointers in binary search. It's going to be left pointer, a right pointer, then there's going to be a middle pointer, right? So what would happen is we'll select the middle pointer and try to identify whether the value on the right is bigger or smaller, or whether the value on the left is bigger or smaller, right? In both cases, and in this position, we need to find a value here, right? So we need to understand if the value we have right now is sorted or not. If the middle value is less than equal to the value on the left, this means everything on this side is sorted, right? And we can find that particular value, and hence we can move run an algorithm to find the value where it is. Similarly, we can understand this is another sorted segment of the array. We can deal with it appropriately. But why can't we just simply run the code like 1 1 1, go through all the values here and just solve that question? Because the uh, O notation timing it would be O for n, which is pretty good timing. The issue is that we have been specifically told not to use this, because we've been told our timing needs to be O log of n. And O log of n tells us it's going to be a binary search solution, because that time is only possible through binary search. One of the possibilities in this case is binary search. So to do that, we use this method over here that we just went over, and that's basically how we sort out this particular problem. So with that out of the way, let's start coding this problem. So first of all, we need to set up our pointers, the left and the right pointers. So let's sort them out. In this case, we'll be referring to them as low and the high pointers. So that's how we've set up our pointers. Then we need to start our loop, and with every loop, as long as low is less than equal to high, we keep on running the loop. As soon as those values, that condition is not met, it means that the binary search must stop, and that's just a generalized binary search condition that you always need to understand. We have that sorted out. Now we need to find the mid value. So we set up the mid value for the pointer. We have sorted out the mid value in this question now as well. Now we need to check if the mid value equals to the target value. If that is the case, our algorithm ends here and we just return the mid value and we're done, case closed. So that is we use the most common things that might occur, and that would allow us to exit the function as soon as possible. So let's do that. With that out of the way, next thing is we need to determine which half is sorted. Basically, we need to understand whether the left half is sorted or the right half is sorted, so our algorithm can work based on that information. So we need to first write the if statement to check if the left half is sorted, and that is through checking if the value on the left side is less than equal to the value of the mid. That out of the way, next we need to check if the value low is less than equal to the target, but the target is less than the nums mid. So basically it will tell us if the target is in the sorted left half or not. Basically now we're testing where the target potentially could be. So we're now testing with the target value. Then we in the else statement we do the opposite, because if that case doesn't happen, we use the opposite case study to test everything out. We have the next if statement there to test again if the where the target is on the right or the left half. And then we do the complete opposite on the else statement here. And after all of that, if none of those cases weren't after the outside the while loop, we need to return -1. Let's run this code and see if this works. And both case studies have been solved properly. And that is how you solve the find target in rotated sorted array problem using binary search in blind 75 question. With that, please hit the like and subscribe button if you got any value out of the video, and let us know in the comments if there's anything you want us to create a video on. With that, we're going to wrap this video up and see you on our next video. Thank you.